This is the Heatkit HM2102 SWR meter and also power meter. If I put the transmitter on, you see that this is the forward setting when I have pulled the knob, and when I push it you get the SWR reading. That's excellent with this antenna. And when we switch to power, it says here 250 watts, so we need to use this scale, and it is almost 30 watts, maybe some less, 28. And when we switch to the scale of 25, it is exactly full scale. But I've measured this transceiver with the amplifier, and it should deliver 30 watts into 50 ohm. So we have some difference between this and this position, and in fact it should give some more power.
And on the internet I found the assembly manual, and that has also the schematic. And this circuit is a normal SWR bridge with coupling coil, diodes, and this sensitivity switch. You go to the meter to check the SWR. This part functions, in my opinion, correct. And here we see the power calibrate in the position of the power measurement. It is this potmeter what defines the sensitivity, and it signal goes via this resistor to the meter, or via this resistor or these resistors to the meter. And as you can see, there's a calibration also in it. And what I found obvious is that you have to select another capacitor here for 2 meter or for 6 meter calibration. And since my Heatkit is likely more than 50 years old, I expect that it is calibrated for the 2 meter band, and I'm going to calibrate it now for the 6 meter band. First, open it.
It is quite nice equipment, and it has a cabinet inside this cabinet, so I just have to remove these screws, and I can lift it out. And this is how it looks like inside. The DC parts and the HF parts are in a closed cabinet, and I have to remove more screws to find what's inside. And this is what I find inside after removing of all the screws. One small PCB, and the calibration parts are not on the PCB, so it's likely done calibrated another method. And this is the potmeter, so I will now connect the whole thing to attenuators and a milliwatt meter to find out how much power really goes through the meter, and probably adjust it to the correct value. First I will measure some resistors if they drifted in value.
This is the circuit board, this is the adjustable resistor, and the R7 and R8 are the other resistors of concern. Let's check those out, and it can be done within the circuit, because depending on the position of the switch, the resistor is open on one side. In this position this resistor is open, and in other position the other resistor is open.
For the 10K resistor I measure 9.4K, and the other resistor, that is 68K, but then I need to switch this one to the other position, and that's 72.6K. This is my reference measurement with the HP 432A power meter, and I adjusted the output that I have 2.5 milliwatt, and via this attenuators and another attenuator to the bridge. In total I have 40 dBs attenuation, so therefore this output is 25 watts. So that's exactly 25 watts full scale here. However, with the fixed resistor I come here to 30 watts, so it needs to be a bit reduced. And I already stapled some resistors, but I think I need an adjustable resistor in place just for this scale. So I now added an adjustable resistor, 250K. I had nothing else laying around, and when I switch on, 25 watt full scale, I can now easily adjust with a screwdriver. I can adjust what I like, and of course I set it to 25 watt, and I hope everything else will be correct. That's it. Better to have two adjustable elements for every scale one than with the fixed resistor, and you have a lot of deviation in it. Then I did the last test with 1 watt, and let's check what we see here in the scale of 25, and there's much more than 1 watt. It's almost 2 watt. So in fact it can be concluded that this kind of power measurement is not very reliable. That's it. Bye.